Dear students, the expected learning outcome from this lecture is you should understand how do lanthanoids occur in nature. How can we extract the lanthanoid from its ore? So let us start our study. Occurrence of the lanthanoids is divided into two parts: lighter lanthanoids and heavier lanthanoids. All lanthanoids do remain together, but majority of lighter lanthanoids remain and majority of heavier lanthanoids remain in different kinds of the ore. And their occurrence, their abundance, their amount varies as the ore varies over there. But let us see what is a lighter and what is a heavier kinds of the minerals. These minerals are divided into two parts. One lighter mineral and other heavy mineral. So what lighter mineral means? What it encompasses, what it possesses. A name itself reveals that it includes lighter, less weight lanthanoids, and here heavy weight lanthanoids will be there. Who are in the category of lightweight? Lanthanum, cerium, praseodymium, neodymium, samarium and europium. But one is not there. Who is not there? Right, promedium is not there. That promedium is radioactive and it is synthesized artificially or during the nuclear decay of uranium. This promedium can be obtained. So here promedium is not included. Now in heavy mineral, gadolinium, terbium, dysprosium, holmium, erbium. After erbium, in the lanthanoid contraction we studied, along with heavier lanthanoids, who do occur? Occurrence of yttrium. Yttrium also. Yttrium is not the rare. Yttrium is not the lanthanoid, but it occurs there. Means in those ores, yttrium also remains. Thulium and lutetium. These do include in heavy minerals. Means majority of these species remain in the heavy minerals. Approximately 160 minerals are there in which these lanthanoids do occur. But commercial point of view, throughout the world, 4 minerals are considered as ore. Means economically the production is viable. Number 1, Bastnasite. Number 2, laterite clays. Number 3, Monazite. Number 4, loparite. Out of that, only few will discuss in detail. But these are the main minerals, or you can say ores, throughout the world. Lanthanoids are extracted from these minerals. Now question arises, how to extract lanthanoids from the minerals or the ores? Because they are in the soil, no, they are in the ore, they are in the mineral, along with the other unwanted things also are there. We want to remove those unwanted things and we want to extract, we want the lanthanoids. So how to get those lanthanoids? Let us study. Okay, before that, what is Bastnasite? Bastnasite is a principal source of fluorocarbonates. These carbonates are there. Fluorocarbonates are there of lanthanoids, and it is supposed as a principal source of lighter lanthanoids. Second mineral was laterite clays. What laterite clays actually mean? Laterite clays include oxides. Along with that, silica remains, ferric oxide remain, alumina remain, and it is a viable source of which lanthanoids? Heavy lanthanoids. Now let us discuss one more mineral, monazite. And this monazite is in our India. On the sea shores are there. Sea sand is there at Andhra or Kerala. Those seashores are rich in this monazite. What is this monazite? This monazite includes phosphates of rare earths. Rare earths means lanthanoids here. In true sense, they are not rare earths, but the conventional name is there. And it is the third most important source for extraction of lanthanoids throughout the world. If I have to talk historical point of view, almost 40% of extraction of lanthanoids was going to occur by monazite. When? In 1980. Later on, slowly, extraction from monazite decreased. Other ores from which extraction was started. By 2010, only fraction is there by which monazite is used for extraction of lanthanides. Then you may be the question, why it happened? In 1980, 40% mining was there for monazite, and by 2010, only fraction is there. The two reasons are there. Number one, cost concern. Means extraction of the lanthanoids comparative to other ores is costly in monazite. And second reason, this monazite possesses thorium, and this thorium is radioactive. So radioactivity, therefore we should be afraid for that, not likewise. But radioactivity, if any mineral is there, or radioactivity, any element we extract, then we need to follow proper precautions, proper care. And that care, those norms, those also increases the cost of the project. And therefore, people decided, in spite of using the monazite, other minerals are there with which we can extract the lanthanoids. And China is the number one in the world to extract these lanthanoids. You will study the applications of these lanthanoids, then you will understand why China has moved to the extraction of these lanthanoids. Secondly, United States is there, Russia is there, Brazil is there. So in monazite, regarding thorium, oxide of thorium, environmental procedure, handling and storage are needed. Second reason for which monazite was neglected. So people were mainly extracting these lanthanoids from Bastnasite. But one good thing happened. In Australia, considerable research has taken place and they set up a project, set up a model in 2014 to extract lanthanoids from monazite. Means economically viable way they can extract lanthanoids from monazite, and it is a good sign for India because India is in reach of monazite. Indirectly, it is rich in thorium. A thorium is a nuclear fuel. So we will discuss not the extraction of thorium, but the extraction of the lanthanoids. So if you see these naturally occurring minerals or the ores, they possess 10% of these rare earths. Means you can say lanthanoids. Only 10% of the lanthanoids is not economically viable. It is to enrich to 60%. And for that enrichment, we need to do primary process on this ore. We need to follow dressing of the ore. We need to treat the ore. So what treatment is done on the ore, that we will see now. What is the process? Whatever the ore comes, that is grounded properly, that is powdered properly. And then from that powder, from that ore, lanthanoids are separated by separation technique. In that magnetic separation method, we have studied. Froth flotation method also is used for the separation by which enrichment of the ore occurs. In case of Bastnasite, froth flotation, hot froth flotation method is used. In that barium sulfate, strontium sulfate, they are heavy, they will settle down. And remaining portion, it will adhere to froth, and that floating portion can be separated, can be removed. So while extracting lanthanoids from Bastnasite, this froth flotation method is used for concentration. Then what happens? 60% of the rare earth oxide concentrate remains. It is treated with HCl, 10% HCl. What is the purpose? To dissolve calcium carbonate. Other things will not dissolve. So it is our first treatment, addition of 10% HCl. Now due to which what happens? Whichever undissolved portion is there now becomes rich in lanthanoids. So from 60% it increases to richness of the rare earth, richness of the lanthanoids increases to 70%. Then 70% of lanthanoids, it majorly possesses lighter lanthanoids. In that cerium also is there, and that cerium can show +4 oxygen state, so it is roasted. So because of roasting, oxidation can occur. Other lanthanoids are there, they remain in the tripositive oxygen state, but cerium can convert to tetrapositive oxygen state. Cerium +3 will convert to cerium +4. So after roasting, after cooling, it is leached by HCl. Previously also it was treated by HCl, but not for longer duration. Now it is leached by HCl, means considerable time is given to mingle the acid with the ore. So that acid chloride will combine with the lanthanoids and the lanthanoid chloride will obtain, and lanthanoid chlorides are soluble in water. So lanthanoid chlorides will come in aqueous medium. But who will not come? Cerium +3, which is converted to cerium +4. This cerium +4 is such a strong metal ion, high charge is there, so it will not allow, it forms, it still oxides, it remains only in oxides, but other do come in what the chloride form. So cerium can be separated only by this chemical method from other lanthanoids. So now where are other lanthanoids? In solution form. What is their form? Chloride form is there. They are dissolved in that acid medium now, because leaching is a time-taking process. It is kept for longer duration in the acid. So now in the solution state, who are there? Lanthanum, cerium already went, praseodymium, neodymium, samarium, europium and gadolinium also. Among these, one element is there who can show +2 oxidation state. Yes, which element? Europium. Europium who can show +2 oxygen state, means now we are with +3 oxygen state. So +3 can be converted to +2. That process is called reduction. So if you reduce this solution, then europium +3 will convert easily or readily to europium +2, and it can be separated from other lanthanoids. One time cerium was separated by oxidation, now europium is separated by reduction. And remaining lanthanoids are there. Those are separated by sophisticated proper separation technique. What is that separation technique? That also we are going to discuss. Separation technique like solvent extraction method and ion exchange method, which are included in your syllabus. If you recall, what we do first, we ground the ore. After grounding, we separate it by froth flotation method and we enrich it by 60%. Afterwards, we treat it by 10% HCl, calcium carbonate gets dissolved, and remaining portion, which is the undissolved portion, is there. It remains 70% rich. 70% rich rare earth oxide is roasted. During roasting, cerium +3 gets converted to cerium +4, and that roasted ore is leached by HCl. Now they come in the chloride form. Cerium gets separated. Whatever the solution is there, leach extract is there, it is reduced up. Europium is separated, and remaining are exposed for the solvent extraction method or ion exchange method, and individual separation may possible. Now let us see how to extract lanthanoids from monazite. This monazite basically is a phosphate mineral, and here separation technique, enrichment technique, enrichment of rare earth oxide occurs by magnetic separation method. Previously what was happening in case of Bastnasite? Froth flotation method. Now here magnetic separation method is used to enrich the rare earth oxide. Now here enrich the rare earth oxide is treated with acid or base. In case of acid, H2SO4 is used for treatment, and for base, NaOH is used for treatment. And due to the treatment with H2SO4, the lanthanoids goes in the solution form after the prolonged treatment in the form of sulfate. But along with lanthanoids, thorium is there, and that thorium remains in the form of the sulfate, in the precipitate form, or in the phosphate form, because phosphates are in sulfate form. Due to leaching or prolonged treatment with H2SO4, lanthanoids will come in the solution form, and thorium can be separated. Remaining lanthanoids are exposed for special sophisticated techniques like solvent extraction method or ion exchange method for their separation. These are acid treatment. Now in the basic treatment, this finely ground monazite is mixed with 70% solution of sodium hydroxide and it is kept in the oven or at a temperature 140 to 150 degrees Celsius for several hours, due to which what happens? Lanthanoids forms their hydroxides. But in this, if water is added, then phosphates are there. Sodium phosphates are there. It can be what? Removed because NaOH is added and remaining precipitate is there, residue is there which has hydroxides of lanthanoids. But still there remains almost 10% of thorium. To remove this thorium, this residue is there, is dissolved in hydrochloric acid, so that lanthanoids will form their chlorides, they will go into solution and thorium will remain there in the precipitate form. Thorium can be separated because thorium has charge +4. And this which solution is there, which is the halides of the lanthanoids, that can be used for further separation. So students, we discuss now extraction of the lanthanoids. Extraction means not separation. Extraction means individually we have not found the lanthanoids. We need to find them separately. So how to get these lanthanoids separately? They have the lanthanoid because lanthanoids have the similar property. Variation in the sizes are there, but to the less extent variation in the sizes are there. So for their separation, some sophisticated, proper, suitable method is to apply. So which method is applied for separation of the lanthanoids? Two methods are included in your syllabus. One is the solvent extraction method and second is the ion exchange method. Let us discuss those methods one by one in the next lecture.